In this video, we'll discuss the moving and additivity principles of area. Now, the moving principle states that if a shape is moved without stretching it, then the area of the shape does not change. That means if I reflect, rotate, or translate the shape, it's not going to change the area of that shape. And that can be helpful when I'm trying to find the areas of irregular shapes. For example, if I want to determine the area of this shape, I want to find something that looks recognizable and see if I can move part of this shape to create recognizable shapes. So if I draw in these dotted lines, I can see that outlines a rectangle. And I notice that if I take the top part and cut it off, it will fit perfectly in the bottom, therefore turning this into a rectangle for which I can find the area. I haven't changed the shape, I've just moved part of it to create the recognizable shape. Then I can use my area for a rectangle of length times width and find that its area would be 660 square feet. Now with the additivity principle, this is stating that I can combine the areas of different shapes to create the total area of a larger shape as long as they're not overlapping. This can again be helpful if I can take some large irregular shape and split it into small recognizable shapes that I know the area. For example, say this is my basement and I want to lay 1 square foot tiles on the floor. And I know that a box has 20 of these tiles in them and I want to know how many boxes I need to buy. And I'm going to assume all these corners are right corners. So that's important because now I can say I can't find the area as it is, but I could split this into 2 rectangles by drawing this small segment right here. Now I know that the area will be the area of one rectangle plus the area of the other rectangle. This right rectangle has a width of 15 and a length of 18 feet, so 15 times 18 would give me 270 square feet. Now this smaller rectangle would be 6 by 7, which is 42 square feet. And so the total area of this shape would be 312 square feet. Now the question asks though, how many boxes do I need? So I need to convert my square feet into boxes. So if I think about it using my measurements, I know that there's one box will provide 20 square feet. And if I follow my chain of movement, this will allow me to simplify the square feet to 1. And then 312 divided by 20 gives me 15 6/10 boxes. But I gotta buy whole boxes, which means I need to round up. So this would need 16 total boxes. Now, that's not the only way I could have solved it. I could have instead drew the line horizontally. And if I look, now I have this upper rectangle and this lower rectangle. And if I find the area of these two rectangles, 12 times 15 is 180 square feet, and then 6 times 22 is 132 square feet. When added together, that's again 312 square feet, and I'm back to 16 boxes needed. So it doesn't matter where we make the split, as long as we can find the area based on the way that I split up the shape. Now, just like I can use addition to find the total area of a shape, I can also use subtraction. If I have an entire shape within another, I can subtract out that smaller area to find the remaining area of the larger shape. For example, say I'm laying new flooring in my 10 foot by 12 foot kitchen, and I have an island in the center of the kitchen that's 3 feet by 5 feet. I don't know how much area is left to lay the new flooring. So if I take my entire kitchen, that would be 12 feet by 10 feet. That's the larger rectangle in this case. And that gives me 120 square feet. And then I don't need to lay flooring at the island. It's already taking up that space on the floor. So that's the 3 feet by 5 feet, which is 15 square feet. So the remaining area that needs to be covered then is the subtraction of the 15 square feet from the 120 square feet, which means that there's a remaining area of 105 square feet that will need the new flooring.